Good morning, everybody. I'm James Dawson. I run the connected car practice for Cisco Jasper. We're currently servicing 27 OEMs across, I think it's up to 18 different mobile network operators. We have about 17 million vehicles on our platform, and we add just over 500,000 vehicles per month. So we talk to a lot of OEMs. We work with a lot of programs, and we get a couple of reoccurring themes. So the manufacturers, or actually the transportation providers, have a couple of issues. They need to derive value from the data that they're producing from their vehicles, from their applications, from their factories, from their dealerships. But that being said, the Internet of Things has exponentially increased the amounts and types of data that these companies are seeing. So there's a few industry trends that we're seeing, right? The scale of this vertical is growing tremendously. We're expecting about 20 billion devices on the planet by 2020. The complexity of the automotive space is increasing. So in connected cars, we're expecting about 11 billion processors in connected vehicles by 2020. And the volume of data is increasing. So according to Intel, we're looking at, for an autonomous vehicle, it providing about 1.5 terabytes of data per day. And to get some understanding of that scale, in the US, the average household, broadband household, is consuming about 450 megabytes per month. So when you talk about cars producing terabytes of data per day, you're going to have some issues with your connectivity, especially in concentrated urban areas. So the high bandwidth sensors on the cars are generating a lot more data. The vehicles need to improve over time. So you need two-way communications with that vehicle, both to understand what the vehicle's doing and to enhance the vehicle during its life cycle. The cloud environment is getting a lot more complex. You know, people used to talk about the cloud. Now there are clouds talking to other clouds being consolidated by even more clouds. And then we're now getting into the arena of analytics and machine learning to enhance these vehicles' performance. So all of this leads to a new architecture for the ecosystem. So instead of trying to ride on kind of the commercial infrastructure that's handling the consumer electronics devices, we're seeing operators creating these IoT-specific infrastructures, kind of segmented away to protect the machine communications from the normal commercial traffic. This gets more complex because now we're integrating DSRC, which is 802.11p, which is a disparate network standard and protocol from what you're normally doing with your cellular communications. And then to make the transition even a little bit more difficult, we're looking at providing those same kind of V to X functionalities through the cellular cloud, maybe on narrowband IoT. And then you add into this satellite and public and private Wi-Fi. So you have a lot more complexity in both how the vehicle handles the infrastructure it sees and how that infrastructure moves the data into your business systems. So if we take one use case, which is machine learning, there's a couple of different ways that people are approaching this. So in-vehicle processing to teach a specific vehicle a new skill or a new behavior. But the more complex one is actually the architecture B, where that vehicle that's just learned something now teaches the other vehicles in the fleet about this new environmental condition that it's uncovered, and has the additional vehicles modify their behavior based on what one or a small pool of vehicles has learned. So that brings us to the problem statement. Now I have devices that are generating data. They have applications on them. How does that device or that person or that vehicle move the data that they have just collected into the application that can make sense of that data And then how does that application allow you to derive business value from that data that you've just received? So, when you're talking about a one-to-one relationship, it's pretty straightforward. But with the broader IoT environment, cars can talk to infrastructure, the infrastructure's talking to federal services about traffic flow and patterns, about the lighting infrastructure. That data needs to go into your cloud, and then your cloud needs to process that data and provide some benefit to your consumer through what it's learned. So we come into a set of challenges. The first one being the complexity of connecting, securing, and managing all of those devices. The second one is, in many cases, the data remains locked inside that distant end. So the enterprise can't derive any real value from it. And then now that you have multiple endpoints with multiple modes of communication, there's no programmatic way to move the right data to the right place at the right time. And then the bigger overarching issue is there's no policy around software control to enforce the data privacy and ownership and to actually secure that data itself. So we think that an intent-based network is needed, a network that understands through configuration of rules and policies on how that data needs to move both across the ecosystem and through your organization. But the challenges remain. So the complexity of connecting all those devices is handled. We're doing that right now, day in and day out. We have an intent-based network. But the programmatic moving and management of that data still remains an issue. So what we propose is an IoT Fabric, a federation of all those distant points that provides policy around the data handling, the data distribution, and the data treatments. So again, the basic premise of an IoT Fabric is to extract the data, to compute the data where it makes the most sense, either in your data center or at the edge of the network, or distributed among your deployed vehicles, and then move that data to the place within your organization or into a third-party application where you can derive business value from the data. So again, what we're proposing is a system of software that runs across a distributed network. These networks are in place today. They consist of the nodes being the vehicles, being the infrastructure in the cities, the consumers themselves, and then doing just-in-time processing, both to provide the data with the lowest amount of latency and to protect your organization from building these massive data centers. And then being able to distribute that data to the nodes that need the data. So again, you can derive business value from this data. So what we're saying is everybody has a lot of data. People have problems turning that data into actionable intelligence. So if you take all of those data sources and put it into the intent-based network, what you get is a way that you can distribute that data with policy around privacy, around corporate business rules, around local regulations, to those applications that register for that data and you approve to get that data. And this allows you to extract the value from the data and drive business outcomes based on that data that you're paying for to be moved from the vehicle to the infrastructure. Brief commercial here. So Cisco is one of the only companies on the planet that can provide you this seamless connectivity and this interactivity between multiple modes of communication. We also give you the ability to do all of that processing on the edge of the network, greatly reducing the latency, giving you the capability to do distributed machine learning and machine teaching, and then to run all of those processes through automation. So the power of the combination of the intent-based network and the IoT Fabric results in a resolution of many of those complexities. Can you play the video real quick?
What is it that makes us unique? As human beings, how is it we come to know when something is right or wrong? How does experience shape our instinct? Is it intellect or something more? It's our intuitive mind that moves us forward. Right now, millions of new gadgets, devices, and things are connecting to the internet every day. More devices now than there are people. Think about that. Think about the complexities of that, the automating of that, the securing and protecting of that. We are entering a whole new era. So it makes sense that we could use a very different kind of network. One that sees all this complexity as the enemy and understands that intuition is the antidote. Because intuition is the most human element of all. It's what drives us, informs us. We try something, we learn, we adapt. We go from there. Now think what it would be like if a network could do the same thing. If it used intuition to drive itself. If it actually had insight and context. If it learned. If it could adapt. If it could predict. Fix things before they break. If it could configure millions of connections, not in months or even days, but in minutes. Think if it could protect based on what it knew, what it had learned from every attack. If it saw threats, even the ones hiding in encrypted traffic, before they happened. So the more you tried to hack it, the smarter it became. That's the network for this new era. Guess what? It's here, now, among us. More powerful than intellect, more human, more intuitive than anything that's come before. Constantly learning, constantly adapting, constantly protecting.
Thank you. Any questions?